Hey everybody, it's Andy again. I hope you enjoyed the first video. Sorry I ran over. I did promise 15 minutes, ended up being 22. But this time around it should be relatively short. We're going into chapter 2, and basically the objectives here are to use technology in creating some descriptive stats and using that descriptive stats to make your um, basically referring back to chapter 1, your diagnosis, your prognosis, and just utilizing that material to the best of your ability. So again, I don't have SPSS like in the book suggests. You can go to Appendix A using that as a reference for Excel. Basically, that's all this video is going to pertain to is the use of Excel because again, I don't have SPSS, nor do I have an Apple device. I'm pretty confident that Apple is relative to the Microsoft, and I'm sure most are very compatible with Microsoft. So if you have an Apple, you downloaded Microsoft. So this should still be very translatory. However, this is not a stats class. It's still a very exercise-based class. This is one of those. That's the way to put it. Kind of a hard data chapter. So just basically knowing how to apply the stats is the mentality, but this is how we calculate the stats using technology. Okay, so we're here. You see my desktop, and right here I'm going to pull up the Excel program. And I've already preloaded data from table 2.1, so we won't have to do this, but just to give you an idea of reasons why we do use data and statistics, this is the performance chart I mentioned in the previous video, and this is my data. So no HIPAA violation here. I give permission to use it. You can see I'm expanding out down here in the corner so you can get a full grasp of the information that we're trying to apply here. And we'll zoom back in just so I can skim over basically all the data we input here. So age, obviously I'm 35 years old. Weight in kilograms, you can see all this. My basic stats and vitals. Down here you can see some currents. It's still a growing process, but here you can see the numbers I input here, which then relate to these numbers here. And there's a way to program it that goes beyond the scope of this class, but just so you could see how data works in our favor, or technology works in our favor to interpret data. So here, right here, calories walking on a flat surface while at a pace of 3 miles per hour. So right here you can see the calculation. I'll click on the cell. So you see this calculation here with the ACSM aerobic metabolism, 3 miles per hour times, you can see the cursor at 26.8, which converts miles per hour into meters per minute. And then obviously this is above rest, right? So the plus 3.5. All right, so here we translate results from the VO2 max test, which was 49, and you can see the I-26, and it basically does all the math from everything else. All right, let's go over here just a little bit. You can see the stats, the current, previous, second previous, first attempt. We throw charts on these so you can see a progressive line. Hopefully, for guys, generally you want these numbers to keep going up. Girth measurements typically want, from body fat percentage, like you see here, the blue line, body fat percentage. Hypothetically, if you had a person start at 54%, you want to see them decrease over time. Likewise, for females, when it comes to girth measurements, like your humerus, femur, and hips, again, generally, and this is just a hypothetical situation, those women want to see those numbers decrease as well, whereas guys tend to want to see things like the humerus, which where you're trying to measure your bicep, tend to want to go up. So here's a really good example of why we apply the data statistics and going into chapter 2 here. So I'm going to click on sheet 1. You can see the data that I already preloaded comes from table 2.1 out of the textbook. Measurement and evaluation, human performance, it's the 5th edition. And we're just going to basically start from scratch here and apply everything you saw on the first slide. So first thing I'm going to do is just kind of space out the cells so that nothing shrinks and doesn't lose continuity. All right. And it'll probably change again after you create some tables here. So first thing, you can see that these tables, they're not exactly tables yet. There's just raw data here. So what I'm going to do is I'm going to highlight the raw data. I'm going to come over here, click Insert, and we'll click on Table. Now this chart or this data already has its headers. If you opt out of headers, it'll say column 1, column 2, column 3, column 4, and so forth. All right, so now we got some data. I'm just going to resize some of this just to be weird about it. Let's see, oh yeah, because of that data down here, so that's why I went all out of craziness. Let's bring that back. I'm going to tighten that one back up. All right, boom. All right. So again, we have all this data ID. Basically, this would be like your name or whatever number. If you're running a research-based study, generally you'll have subject here, and it'll say subject 1 through 10. Gender, males are always going to be 0, females always be 1. Age is dependent upon years. Some mathematics may change that. I doubt it, but we're just going to roll with years for now. The weight in kilograms, as you can see back here, that was the first thing I had here because most biomathematics goes off of mass, not weight. So with the difference in your aerobic metabolism, or we'll get into the test here in a second, but this is the 12-minute mile. It should say VO2 max Cooper 12-minute GXT. Got it. Boom. All right, so that's what that should say. I have it coded to multiply out into pounds because the math formula requires in pounds. So there are some differences. This is a good example of why we start with one number and end up with another. So going through, moving forward, you got your weight, your age, your height in centimeters, and steps per day. So let's move over to this table. So first, we want to start coding a few things to basically teach the Excel program what we're looking for. So age, the end value should always be 10. At least that's what it says in the chart. We'll get into more of the nitty-gritty stuff here in a little while. In the future chapters, we'll understand what N is, but for right now, just know N is a column name. So minimum, right? We want to know what the minimum out of all of this data is. So we hit Enter, and we hit equals, or correction, we click on the cell, right? And then we hit Enter. I'm going to escape out of that so I can explain it. Right, so click on the cell, we hit the equal sign. Now we're trying to do a little bit of coding here. So what we're trying to find is the minimum. So I'm going to type NIN, right? Gives us the option for min. A few clicks will set it up here, and now we highlight the data we're looking for. So we want the minimum of the ages. Here, go through, do that, and I just hit the enter button. Boom, 19 is the minimum. And we'll repeat the same process. Min, click on it several times, go to weight, kilograms, enter. And steps. All right, great. Next thing we do is we pretty much do the same thing for the max. Over here we type in max. Get the max volume, the largest volume. We repeat the same process for age. Sorry. See how I messed up and I went over here and clicked on it. I didn't have to hit escape to back out of it. So again, Excel is a pretty nifty device to use, or technology to use, because it's a learning program. So max weight, go over here. All right, so I made a mistake somewhere, right? We want to open this back up. The easiest way to do it is just in this point to start from scratch. Max. Make sure we have that highlighted, and we're still looking for weight, so we go to weight. Boom. Go over here, type in max again. Sorry, this is slightly repetitive, but needless to say, we're going through it. Max height. And then max steps per day. Dang it, did it again. Because I didn't click on max enough. Max. So I gotta make sure it opens up. So we scroll and you see these blue, this blue highlighted area. Boom. Alright, so mean, we all know mean is average. So we don't type in mean, right? We'll get some different options here, but that's not what we're looking for. We're looking for average. Average. See, not average deviation, but average. Boom. And now we're looking for the average age here. Let's see if we got some AV or average. Let's do weight. All right, let's see if this over here, click that down, or wait, no, we don't do that yet. Do this. Now we teach it to do that, which is now, no, that didn't work. Oh well, I try to do a little shortcut. Sometimes it works, sometimes it doesn't. Just depends on how the data's set up. Here, maybe average. When we're in height, go back to height. Boom. And there's other ways to skin this cat, but this is just the simplest way to do it. All right, so now we got all this data, right? Now what we're looking for is standard deviation. And we're going to type in standard dev, right? There's different options here. STD, EV, standard deviation. That's the basic one. So standard deviation, I don't remember what the book says, but we'll just highlight some area here, right? Wait. Standard deviation for that, 2.75. STD, DEV, and we're going for weight in kilograms, STDEV, and deviation. We'll click on this one here, and then STDEV. Click on that one once more, and we'll do the deviation for the steps per day. And there you go. Pretty or easily to manage. Obviously, all you have to do is hit enter, type in the function that you want it to do, min. You can also go up here to auto sum and hit more functions to figure out different things that you want to do with it. But this is, again, a very basic concept of how to apply the data, use the data first of all. But let's move on to a little basis of what's the word? That's not the word I'm looking for. I'm looking for a check on learning, so to speak. All right, so here in this practical application I've set up, we will look at how to calculate BMI and calculate resting metabolic rates. So if you look at the BMI, you see that we need to have a ratio of kilograms over meters squared. So here's what we have, this data we're working with. We have kilograms in this column, but we also have centimeters in this column, which means we need to convert centimeters into meters, and then we have to square the meters to get this meter squared. So there's a little bit of effort that has to go on, but let's get started. All right, first things first, right? Kilograms, we're gonna go ahead and hit enter. So we already have our, what's the word? Function set up. We're gonna go over here, click on kilograms, and we're gonna hit the backslash button, which in pretty much any Microsoft Office suite, that's considered the division symbol. The next step we need to do is we need to program the Excel spreadsheet here to understand that we're trying to convert meters or centimeters into meters squared. So first thing we'll do is we'll open up a parenthetical, click on the height. We're going to hit the star, which is multiply in this function here, and then we hit 0.01 to move the decimal place 2 places essentially, but that's the mathematical way to convert centimeters into millimeters. Close that out, right? Now we have meters, but we still need meters squared. Hit the raise function, which should be shift 6, and put a 2 behind it. Next thing we do is we smash on the enter button, and we get their calculated BMI. So here you come back up here, you can see or modify the math if you messed it up. So if I had an extra 0, obviously that makes a big difference. Come back here, remove the 0, enter, there you go. 18.36 or 37 kilograms over meter squared. Over here, we have this calculate resting metabolic rate. You can see the two formulas that I have associated for this method. This is the Mifflin and St. George model. So we're calculating a cofactor with body mass, height in centimeters, which is data we already have collected, and age. And that's also data we already have collected. So here, we'll hit enter, and we'll add in the coefficient here. Parenthetical, hitting the wrong button. 9 times, I'm going to take my mouse and click on this cell over here, close it. I'm going to hit plus, because these are zeros, right? Zeros, that means they're guys. So we're going to, that doesn't mean much right now, but if you pay attention to the model, there is a specific model for the gender. Let's see here, 6.25 times height in centimeters, close. For men and women, we both subtract the age. 5 times age, close parenthetical. But men, we add 5 back into it. Boom. Gives you a resting metabolic rate. So back up here, we have the coefficient, 9.99 times E5, which is the cell. We go E5, and you see where that crossed over here. Back over here. Plus 6F5, again, still in the 5th row, but the F column. And you can see that measures up here. We have D5 plus 5. So this is a real simple way to use technology to basically factor in anything that has to do with biomathematics. If you want to, you can take some time to program your Excel spreadsheet or whichever preferable programming you have, and you could do a couple of these. I would prefer to do at least 1 or 2 of each, where you see the ones and the zeros, so you can have practice in the males and females. Make your mistakes. When you make your mistakes, again, you click on the cell and you go back and check the math. So over here, Andy is a male who ran 12 minutes on a VO2 graded exercise and concluded with a result of 1.5 miles. His weight is 230 pounds and 5'10". Use the following formula, right? VO2 in milliliters, kilograms per minute. This is the formula, so you'll punch in here, right? 35.97 multiplied by distance in miles. In this case, it would just be 1.5. Supposed to close the parenthetical here, so we'll come up here and modify the address bar. Minus 11.28. Boom. And it says Andy is a stellar athlete, right? So this is an ML kg and per minute. And you can change any of this data here. Specifically, this is pretty easy. The 12-minute Cooper test is a pretty easy exam to perform on people when you're trying to get a good baseline on what their VO2 is. But we'll talk about the different types of testing later on in the chapter, specifically when we talk about the Yeah, basically just the testing of that particular muscle group or VO2 group. So hope that was informative.